Okay, let's go ahead and get started with this presentation. Um, my name is Jeremy Zeiss. I'm one of the engineers here at Allan, and uh, I guess this presentation is part of a new series we're starting for design professionals. We're basically going through our best practices document, um, chapter by chapter. And this is the first presentation of the series where we're going over chapter one. And next month we'll have the chapter two, and we'll go through basically all of best practices that way. Um, so for this presentation, if you guys have any questions, feel free to uh, type your question into that, I guess, question section for the GoToMeeting or GoToWebinar, and we'll be able to see it and answer it. But with that, let's go ahead and get started. So, like I said before, this presentation will be going over Chapter 1 of Best Practices, and that is the Design Guidelines and Pre-Construction Considerations section. So right off the bat, we'll talk a little bit about what Best Practices is. And so Allan Block, we've had over 25 years of experience in the retaining wall, segmental retaining wall industry, and throughout those 25 years, we've done a lot of research, a lot of design, and a lot of field experience. And throughout all of that, we've really learned what it takes to design walls that are going to last a lifetime. Now, retaining walls in general are a very successful product. They hardly ever fail, um, as long as they're designed right. But every so often there will be a failure. And what this best practices is really an industry-wide initiative um, to really hit zero wall failures. I say industry-wide because we've done a lot of work with NCMA. The other SRW companies as well are also invested in this. Um, it's basically a way to spread knowledge throughout the industry about how to properly design retaining walls to hit that zero wall failures. Uh, one failure is too much in our eyes, and so that's why it's at zero wall failures. A few big things that we try to hit with these best practices is that we really want to kind of pull the design or the control of the design away from the contractors on project and put it into your guys' hands or put it into the site civil's hands. That way we can avoid those designed by others that you see so many times on projects. We can also get the design started for the retaining wall much earlier on in the process. That's something that's really important for us. And then also, we want to get more people involved in the retaining wall design. That's something that we really try to hit. Uh, Again, a big portion of this is just planning and getting things done early with the design so that we can address issues before they become very pertinent to the wall design and where they would normally cause delays and change orders, which we hate to see. Uh, but really, I guess in general, all of our projects are different and should be designed according to their specific constraints, and that's another part of what we'll be talking about today. Um, so moving into what Chapter 1 is, Design Guidelines and Pre-Construction Considerations, basically what we're going to be talking about are the steps you need to think of prior to designing your wall in order to minimize problems later on. We're going to find out kind of what needs to be considered on a specific project by looking at the design considerations and I guess popular areas where sometimes people overlook or certain situations that we need to make sure we really focus on before we design the wall. We're also going to talk a little bit about what we need to have prepared outside of designing the wall. So that could be what we need for the bidding process, what needs to be included in the design package, things like that. So overall, this first chapter is kind of has an overarching theme of getting prepared, making sure you've got a checklist for what needs to be done. It's really that making sure that you are being proactive rather than reactive. And that's a common theme you'll see throughout the presentation. And the reason that this is so important is because when walls aren't designed correctly, they're more likely to fail. And having the zero wall failure initiative, that's something we try to avoid at all costs. So as long as we're able to prepare early, we can, like I said before, address these before they become really big issues. And another thing is that if we can catch things early on, we can avoid making changes later on in the process because those are expensive and time consuming. And everybody hates having delays on their project. They hate the costs that come with that as well. And of course, a big part of any type of design is we like to see things, or we like to address things that are normally overlooked or that can sometimes be overlooked. So if we can eliminate those oversights, then our walls are going to be a lot more successful, and we're going to be able to address things that will have major impacts on our wall later on. So moving into our first section, I've included our best practices document as a handout for you guys all. If you see the handout section, I'd encourage you guys to follow along if you can. You'll also see the spec book in those handouts, which I will be, I guess I'll be tying into the presentation a little bit, so you might want to look at that as well. But if you're following along, I would go to section 1.1 of our best practices, where we'll be talking about meeting the owner. This is what we say should be the first step of any design of a retaining wall. When you do this, you're going to get a lot of information about the project. One of the most important parts is you're going to see if the wall is kind of adhering to any unique application. So is this wall going to be a water application? Is it going to be GRS IBS, a bridge abutment? Will it be a cut site or a fill site? So things like that are things that we really need to pay attention to and note before we start designing the wall, because a lot of that will drive how our wall is designed. Another thing is that this is the best time where we can learn about the overall need for the site. Is it going to be a commercial or a residential site? Is it going to be a government project? Are there going to be surcharges above the wall? Any drop structures or property lines that might interact with the wall or the reinforced zone? Are there any building foundations that need to be addressed? So all of these types of needs for the wall are things that the owner might know offhand, or they might know that the site is going to be used for something where one of these might come up. Another thing that it's great for is we can ask that owner what documents are going to be required. That conversation with the owner is easy, and it makes sure that there's no surprises later on when we find out we might need to submit a certain document that we weren't initially planning on providing. Another thing is that this meeting with the owner is going to help explain what your scope of work is as the engineer or the site civil, the one who's kind of, I guess, the one who is managing that project or controlling the design. That is where you're going to have a conversation with the owner and say, hey, this is what falls under my role as the overseeing engineer. And it just makes it clear to them what you'll actually be doing. And then lastly, it's going to help the owner know, and you know as well, what you need to provide later on in the design. If this gets overlooked, any of this information, and you don't get a lot of information on what the site needs or how you need to cater to the site, you might start designing your wall in the wrong direction. So that's really why we include this section in best practices. Now moving on to section 2, determining when engineering is required. So just because engineering isn't required based on the local codes or municipalities regarding wall height, that doesn't mean that engineering should be skipped. So it's very important to not just rely on the local codes there. Really, if the wall has any, I guess, abnormal site conditions, then you should require engineering. That can be anything from poor soils, terraced walls, steep slopes above or below the wall, if there's high seismic loading, any surcharges above the wall. Anything like that would be considered a special case and should require engineering. Uh, it's very easy to skip out on these if you see that legally your wall can be designed without requiring engineering, but taking the extra step to recognize that even a small wall might need engineering is a skill that's going to help you kind of stand out and keep your design walls standing out or standing up for decades. Um, and again, those site considerations that I said before, any single one of those is something that can normally cause a standard wall to fail. So we really want to make sure that we address it early on and notice that we have to have engineering for this wall. Now, moving on to our utilities section, what we want to do here is we really want to make sure that everyone who's on the project is aware of where both existing and proposed utilities are. We want to make sure we consider both existing and proposed so that we can see that what's already there, is it going to affect the construction of our wall, and our proposed, we want to make sure that what we're building doesn't interfere with any plans for that. And we really want to make sure everyone's aware of it by adding it to the site plans. That's an easy way to make sure everyone has access to where those utilities are going to go, and really just make sure that everyone is aware of it. Now, this is another very important reason why we want that site civil controlling the design instead of the contractor, because that site civil is going to already know a lot of this information and have access to those plans where they can update them and send them out to everyone. So just another reason that we push the site civil controlling the design. It's important to note that anytime there's utilities, we like to keep them outside of the reinforced zone of the retaining wall. That way we can avoid any interaction with them. We just like to stay away from them. And the reason for that is because if we ever damage a utility line, that can lead to really expensive fines and delays. And of course, any of that is going to cost more money and time, and that's what we hate. We try to avoid that at all costs. Another important thing to note about utilities is that any existing utilities or proposed can really, I guess, drive buried block and reinforcement requirements that are going to need to be designed as part of the wall. So we like to be aware of that so that moving forward with the design, we know if we have to make any special arrangements for those utilities. Now, for the wall layout, height, and geometry of our wall, a few things are important here. One is that the design of our wall is mostly going to be based off of what's provided on our site plans or our wall layouts. And this is going to include how the walls start, how they finish. It's going to show the shape of the wall. Are there going to be mitered corners or curves? What will be the conditions above the wall or below the wall? And if there's going to be any surcharges above the wall as well. So all of this will kind of be shown on the site plan. And one example of why this is so important is because, let's say on your site plan, your retaining wall shows that it has a few mitered corners on it. One thing that we always say here at Allan Block is that if we can avoid those mitered corners by replacing them with curves, we like to see that whenever we can. The reason for that is because, of course, anytime you have a mitered corner, it means you have to cut blocks, and anytime you have to pull out the saw to cut that block, that's more money on the project. That's going to cost more. Another example of why it's important is if we see that on the site plans there's a parking lot below the wall, we might have to bury more block to account for that, so that when that parking lot is excavated, the bottom of our wall doesn't get dug out. So again, it's really important to see all of that. And anytime we have to maybe adjust our wall after we see these site plans, it's something that we have to make sure we get approved by the owner. If we make a change and design a wall based on that change and we don't get it approved, it can lead to discrepancies between what the owner expects and what you've designed, and that's something that later on can cause a lot of delays, and we want to avoid that at all costs. A good place to go to learn more about this is the wall design checklist in our spec book. That's what this image is here. It's on page 10 of the spec book that's attached as a handout for all of you guys. And basically, it's just a list of things to consider when you're looking at your site plan to make sure that the wall layout, height, and geometry includes everything that's needed for the design of the wall. When you're looking at these site plans, one of the most important things you can do is ask questions. You really want to make sure everything is addressed and you're not unsure about anything. So if there's something above a wall that's not labeled on your site plan, find out what that is, because that could be a huge surcharge or it might not affect the wall at all. So it's really important to be aware of what every part of that site plan is, and you really want to make sure that you're confident that you know what each part is. Now, moving on to the geotechnical report, I want to start off with a big positive here. Lately, we've been seeing that a lot more geotechs are getting involved early on in the design phase for a retaining wall, and that's something that is so important. I can't stress it enough. When that geotech gets involved on the project and they get involved early on, we're able to get a geotechnical report, a soils evaluation, all of that right at the beginning of a project. And when that happens, a lot of those factors, that's those soil conditions, groundwater, settlement, global stability, all of that is has a high impact on our wall stability and how our wall will be designed. So the sooner we can get that, the sooner we can come out with accurate designs. Now, also without any geotechnical reports, we can't be sure of any of these site conditions. So basically anything that's not on the surface, we won't have any information about, which can harm us later on when we're trying to design our wall. It's also important to note that these aren't always available. So if you're working on a residential project, there's a good chance that your wall or your project won't have a geotechnical report to go with it. So I guess when you can, be sure to get them. Oftentimes it comes down to the owner to provide these, or it's the owner's responsibility to have them. So I guess be aware of that as well. And then from the geotechnical report, we get a lot of stuff about our soil conditions. So that's why the next section is understanding site soils. Now, the biggest thing I want to stress here is that we never want to assume anything about the site soils. We want to make sure that what we're putting into our design we know. That's the biggest mistake that any designer makes, is that they assume the site soils. So basically, the type of soil behind the wall is what determines a lot about what kind of pressure is exerted on the back of the wall. And every soil is going to be unique and react differently to water, surcharges, settling, all of that. So designing any walls using poor foundation soils can lead to huge failures. And that's why it's so important not to assume, and make sure that the soils that are on the site are, I guess, either suitable for the design of the wall or to put as the infill. And if they're not, it's important to know when we need off-site soils. So that's how when we come down to this foundation versus off-site soils. If your foundation soils aren't good enough to be used for the wall design, you're going to have to bring in more granular off-site soil with a higher friction angle, or things like that, to make sure that the soils you use for your project benefit the design and make sure that it works. Now, the next step we have in here is to plan a site visit. So the reason for this is because not everything about the site is going to be shown on your site plans. You're going to use this visit as kind of a verification for your site plans in your geotechnical report. You'll want to go out there and look at the site and see if your geotechnical report said that soils are one way, and you go there and you see that that's clearly not the case. That might tell you that you need a more updated geotechnical report. Or if you go to the site and you see puddles like you see in this bottom right-hand picture, that might tell you that your site has some drainage issues that you weren't initially incorporating into your design. That's why it's so important to do this site visit before you design the wall. You'll be able to see these things that you might have to address later on, uh, but early enough to where it won't be a problem while the wall is being installed, and you've thought about it before it becomes a problem. Uh, so another thing with the site visit is it's really going to help ensure that um, everything on our site plan and our wall layout is accounted for. And just in general, being more familiar with the site is going to make designing the wall so much easier. When you're familiar with it, you know you have a good reference of where everything fits into place and certain areas that might need a little more attention to detail than others. So that's why it's so important to have a site visit before. Now, moving on to temporary load conditions. Uh, this is something that I guess again comes back to not everything shown on the site plans is accurate for the wall in terms of, in this case, temporary load conditions. So yes, lots of surcharges will be shown on the plans, but lots of surcharges that will affect the wall won't be shown. For example, here in Minnesota, we just went through our snowiest February on record, and with that comes a lot of plowing. So anytime people plow snow against the wall or on top of a wall, anything like that, it's going to act as a surcharge when that snow piles up. So that's something that might be a temporary load consideration. You've also got, during the construction of your wall, you might have heavy machinery going above that space or above the wall, and that's going to affect the wall as well as a surcharge. So it's things like that that you might not be considering on the site plan, but will still affect the wall. Another thing that comes up here is fences above the wall and impact barriers. Anytime you have one of those above the wall within 3 feet from the back of the wall, you're going to, uh, I guess, impose forces onto the facing of the wall from that fence, either from wind loading or from impact. And that's another thing that you might not initially think to consider as a load, but it's going to affect the wall. The reason that it's so important to consider this is that uh, overlooking any of it can lead to failures of the wall. If you're not accounting for a surcharge that is temporarily above the wall, um, that wall might undergo some pressure or have some forces on it that weren't accounted for in the design, and that's an issue that we need to address early on. And like I said before, the biggest thing is to really be proactive here instead of reactive. So we're looking at where those loads might be and how we can address them early on and make sure that the wall is designed to accommodate any loads that come up in the lifetime of it. That's why it's so important. Now, moving on to our scope and design methodologies, uh, right away, it's important to know what your responsibility is as the engineer. Um, that's important because that way you're making sure that what you're accounted for gets done correctly. It's also important here to make sure that the owner is aware. When the owner is aware of what your responsibilities are, it avoids any confusion that might happen later on in the project, and it avoids them really, I guess, coming to you with questions that might not pertain to you or might not be in your wheelhouse. Of course, you can help them if you're able to, but it'll avoid them potentially, I guess, blaming you for things that aren't part of your scope. This is another reason why it's important to have site civils controlling the design here. They're very, lots of them have experience with what they are, I guess, what falls into their roles. A good example of where you can go to look at suggested roles for engineers is in the NCMA design manual. Their section 3 talks about some of the suggested engineer roles, and that's a great place to really go through there and look at what's suggested for you to do. Moving on to the methodologies. So there's a ton of methodologies out there. You know, you've got AASHTO, you've got NCMA, things like that. And not all projects or states or areas require the same methodologies to be used for their wall design. So it can get a little confusing sometimes, but uh, it's important for you to know what's required for your project. That way, if you avoid designing in one methodology and the project requiring a different one, and the design might have to be redone. Uh, Good news is that the Allen block methodology fits the requirements for all of the NCMA, AASHTO, and others as well. Uh, and then it's worth noting that if you're going to do any DOT work, AASHTO is usually what they would use as well. So being aware of which methodologies are used in which situations or areas is very important so that you're able to design the wall correctly the first time to meet those requirements. Now, moving into the minimum design safety factors. So, in general, the minimum factors of safety aren't going to change very much. They're pretty consistent with the standard minimum safety factors that you can see in this image here. Uh, I pulled this image straight from the best practices manual. So, of course, if you're following along, you'll see that as well. But it is worth noting that while it's not common, sometimes higher factors of safety might be required based on local codes and municipalities. And if that is the case, it's important for us to be aware of it early on, um, to make sure that those factors of safety are hit and they're met with our design. The last thing we want is to have a special case where a factor or a safety factor is heightened for a specific area and we designed it for the standard. So it's important to be aware of any special cases with these, but they shouldn't change too often from the standards. Now, moving into coherent gravity mass and connection strength considerations. So, the coherent gravity mass is made up of the wall facing and kind of the reinforced zone behind the retaining wall made with the geogrid and the compacted soil. Uh, what's worth noting here is that a lot of factors of the geogrid are going to be used in our wall design, and will determine kind of the internal stability of our wall. So the reason that this section is here is because Allan Block has done a ton of testing and studies and over the years, and we've really found that in general, if you're using grid lengths that are 60% of your wall height and placing them on every other course of your wall is going to lead to a reinforced mass that's going to easily distribute any of the internal pressures of a standard wall. Now, of course, I said standard wall there because if there's any special considerations like a surcharge above or any slopes, anything like that, or a tall wall, your wall might require longer geogrids or more buried block or certain things like that where they go beyond the standard. So we've done all of the testing to see what works best, but that doesn't mean that it works for every situation. So it's important to really look at your unique site, your unique project, and say, how does this affect my wall? Am I going to need to extend my geogrids? Do I need to have more layers in certain areas? So basically, it's just good to be aware that the standards aren't always applicable. And just like everything else, it's a unique application, so it might require a unique solution. Now here is probably the biggest section of this first chapter of best practices, and that is contractor requirements. The biggest thing we stress here is that we want to require our contractor to be certified. We want them trained and knowledgeable on Allan block or whatever SRW is being used for the project. Here, us at Allan block, we've trained over 1,000 contractors and gotten them certified. Every year we do that. And NCMA also offers certification programs as well for contractors. They're almost always accredited as well, to give the contractors kind of another reason to go through them. But it's so important to require that our contractors are certified. That way we can ensure that they know how to properly install a wall and they know how to avoid common mistakes. So when they sit through a full day class on how to properly install Allen block, they're learning the tips and tricks that are needed to be successful in that and to avoid common mistakes that can lead to failures. And when one failure is too many, uh, I can't stress enough that having a contractor who's certified is so important. Um, it's also worth noting that other classes are offered where contractors and wall installers can learn more about special applications like uh, GRS, IBS, or fences, things like that. Um, when those contractors and wall installers go through those classes, they might be the ones to approach when you have a special project like a GRS IBS project. You'd want to talk to someone who has gone through a GRS IBS class and knows some of the important details about that as well. Uh, what I like to kind of draw a connection with here is if you are at your home and you have a plumbing issue, when you call up a plumber, you make sure that they're certified and they've gone through training and they know what they're doing to make sure that when they fix something, it gets fixed correctly. That's the same thing we're trying to do here with our contractors, except with building. We want to make sure that these walls get put up correctly, and the best way to do that is to make sure that they've gone through the proper training to do that. Moving on to section 13, we talk about manufactured product specifications. Uh, Here, we're basically going to make sure that the blocks that are being used for a project, have undergone the testing that's required to meet all of the requirements. Some of those common requirements are going to be compressive strength, water absorption, freeze thaw resistance, geogrid mill reports, and some more depending on where you're located. Uh, that ASTM table down at the bottom there shows some of the requirements that are minimums. Uh, a good note here is that Allen block does meet all of these requirements, and we make sure all of our blocks are always up to date with this testing information so that they can be used on any project. But what's really important to note here is that a product must meet the requirements to be used on a wall project. If they don't meet the requirements, then a different product has to be used. And another thing that's important to note here is that sometimes contractors will try to switch out the block that's spec'd for the project in order to save some money or lower their bid, but sometimes that product that they're trying to replace it with is not equivalent, and uh, it doesn't meet the standards or the requirements that are necessary for the project. So that's why it's so important to have that site civil controlling the design, because they're aware of these requirements, and they would have a better idea of which products can be substituted and which can't. It's really important to get these products specified early on, because that means that the earlier you get the product specified, the earlier you can start designing with a specific project or product. And like everything else, the sooner you get that out of the way, the sooner the design can begin, and then the sooner you can address any issues that come up. Now, freeze thaw durability. This is something that isn't going to affect everyone. As you can see there in that map, there's three main zones. It's worth noting here that this map isn't just someone didn't just come through here and say, "Oh, Minnesota's cold, put them in zone 3." Uh, this is done with very specific testing and studies to make sure that uh, they really had good lines of who is affected by this freeze thaw and how they're affected. So anytime you fall into any of these zones, it's important to, one, I would say review our best practices manual to see the specifics of it. And some basic checks you'll want to make are you'll want to look at this map and see what zone you're in. Find out how you're affected. Are you affected? Anything like that. And then if you are in the zones, some things you'll want to know is general winter things like de-icing salt or anything like that, we're not going to want to put directly on top of our SRWs. Um, Really, on top of any concrete product, as you guys all know, that de-icing salt can kind of very slowly degrade any concrete product. So we try to say keep it away from the face of the wall and the top of the wall. You can use a stone cap as a divider for any steps or walkways to keep that de-icing salt off the wall. Another thing is that we want to avoid any water running on top of the wall or down the facing of the wall. This is just a good rule of thumb in general. Retaining walls don't like water, especially if it's somewhere that water can freeze and expand. So really we like to keep running water in these areas away from the top of our wall and any facings. And if your wall is susceptible to any of these situations, like the de-icing salt or any water running down the facing, you might want to consider sealing it. And sealing it can really just add an extra layer of protection from any of this stuff and will really help avoid any damage over time. Because basically, what we're trying to do here is keep anything that can cause damage over time to the wall, keep that away from the wall. We like to keep our walls as safe as possible, and the best way to do that is keep away any issue things like those I mentioned before. And then lastly with this, of course, make sure that your freeze thaw durability requirements are met by your product, depending on what zone you're in. Now, moving on to section 15, which is the pre-construction meeting. What I'll say here is that you'll want to require a meeting with any parties associated with the wall design. So anyone who might come in contact with that wall or interact with the wall at all. That can be so that you'll want the owner, architect, site civil, the geotech, the wall designer, the general contractor, any fence installer if there is a fence above the wall, the wall builder, local utility representative, inspectors, anyone like that to join in on this meeting. Another great person to have at this meeting would be your Allan Block supplier representative or the representative from Allan Block, because they'll be able to help you facilitate the meeting, answer any questions that anyone has, and they've always got a good idea of best practices as well. And so with this meeting, we really try to make sure that site civil who's controlling the design of the wall has this as an action item to have that pre-construction meeting. It's going to make sure that everyone who might interact with the wall is on the same page and they understand the best practices that needs to be used on the project. A good thing to use as kind of an agenda for this meeting is the AB construction and inspection checklist from our spec book. I mentioned the spec book before, but the construction and inspection checklist that's there is great to be used as an agenda for this meeting. You can just kind of follow it straight through, and each of the points is a good talking point to address with everyone. Now, the reason that it's so important is because, like I said before, it's going to make sure everyone is on the same page. It's going to make sure everyone is aware of the requirements that need to be met with the retaining wall, and it's also going to establish each person's kind of scope of work for any parties involved in the wall design. That's why that's so important. Now, moving on to site visit during construction. So the reason that we have this is basically it's great to check in on your project. We say that each of you guys should, when you design a wall, to visit at least 3 times on the project. One at the beginning before the project starts, one random time during the construction, and then one at the conclusion of the project. So we like to have that as a part of the scope of work that you give to the client, and really include that in something that's I guess not required from you, but uh, we like to have that as something that you plan on doing and that's communicated to the client or the owner. So, of the three visits, the one at the beginning is basically there to stress the need for compliance with any approved design. So, we want to make sure that how we design the wall is how it's going to be built. Um, that's the main point of the first visit. Now, the random visit during construction, you're going to make that to make sure that any of the approved plans are being followed. And another big thing here is that you want to answer any questions that any wall installers have or the contractor has, because this might be uh, the best chance you get to come in contact with them. And they might ask you some questions about the wall. So it's important to, I guess, really know those answers as well. If you're not sure, it's always a great idea to contact your Allan Block, I guess, representative in your area. They'd be happy to assist you guys at these site visits and can oftentimes answer a lot of those questions that the wall installer or the contractor has. So I would always encourage talking to your Allan Block representative to join you on that meeting. Now, the last the last site visit would be at the conclusion of the project, and really what you're doing here is you're just making sure any special conditions were met or making sure all the instructions were followed correct, and you're looking for any final concerns on the project. Obviously, hopefully you don't have any concerns with how the wall ended up, but it's important to check up on that wall. And with these meetings, there's really no need to limit it to 3 visits. I'd actually encourage more than that if needed, because anytime you get to make those visits during the construction of the wall, uh, you lend yourself the opportunity to answer any questions that those wall installers or the contractor has. And that way, they feel confident about what they're building, and it avoids any possible mistakes that they can make moving forward. If they're not sure about something, they might just make a decision, and that might be the wrong decision. So we want to make sure that you're available there to answer any questions that they might have. Uh, Another thing that's important here is that for each of our visits, we want to make sure that we document them. Anytime we document is going to be very helpful, not only to you, but also to your owner. It shows them kind of uh, I guess, what's been happening with their wall. Has everything been done correctly? Have you been overseeing it? It shows them that you're giving them some quality assurance by saying, hey, I visited here and I made sure that everything was going well and everything was uh, going in line with my design, basically. So section 17 is all about the construction drawings. Um, Construction drawings are super useful. When you have construction drawings available, the image here is actually from our AB Walls design software. Uh, AB Walls is a great example of this, because what it does is you have the opportunity to print off a shop drawing like the one shown here. This is just one page of it, but it's going to be such a great resource uh, for the wall installers, for the contractor. It's going to show them where their geogrid layers are. It's going to show panel views, any special instructions, basically all of that. And if you're wondering what to include on those shop drawings, I would encourage you to, if you're following along, you can see this as well, but I'd encourage you to look at Chapter 1 in Section 17 of our best practices, and it's going to show you a list of what to include on them. Like I said, these are so important because it's going to provide a lot of instruction for the wall installer who might not know anything regarding special instructions or what layers geogrids go on. Um, and having these details available to them and documented is a great way to make sure that uh, they're, I guess, accountable for making sure that everything is installed correctly. Like I said, AB Walls is great for this. Uh, it's great at getting that output right away with one click of a print off. Now, moving on to the bidding process. This is, you guys all know, this is a very important part of any wall design. What we want to stress here is that we want to, we really want the design to be part of the bidding process. We want to make sure that that design is available to anyone bidding. A big thing here too is we want to know what the owner should provide and what you need to provide. Ideally, the full design of the wall would be provided by the owner so that any requirements demanded by the project are really clear to anyone bidding. That way, if the people bidding know what, I guess, special conditions the wall is going to have, they're able to give you an accurate bid. Ideally, we say everything needed to complete the project should be provided on as part of the bid. If that doesn't happen, it's very easy for inaccurate bids to come in, and if those are approved, it's going to lead to changes needed down the line, which of course costs money and time as well. So we want to avoid any confusion, any missing parts of the bid. We want to make sure it's all there and available for those included. Now, the last section here is section 19, where we talk about quality control and assurance. The biggest thing here is we want to provide detailed requirements for the testing and inspection firms to use to make sure that they have everything they need to evaluate the wall correctly. We don't want to assume that they know exactly what they should check for every wall. Like I've said a few times this presentation, every project is unique, and that means the inspection for the wall is going to be unique. So by you providing them with a list of special conditions that were used for the wall and what needs to be evaluated, that makes sure that the inspection that they're doing is going to be a quality inspection. And with quality inspection comes quality assurance, making sure that that wall really does meet the standards that are required for a wall that's going to last a long time. And again, when you're giving them these requirements, that's documented. We want to document everything. Documenting is a great way to ensure that everything was hit and really make sure that what you said needs to be inspected gets inspected. So that is all of Chapter 1. We've kind of gone through a broad overview of best practices in general, but in conclusion, there's 3 main points from this first chapter that we want to hit. One is that we want to make sure that that design gets out as part of the bidding process. That way we can get designing the wall early on. We can avoid any, holdups later on in the project and really just make sure we get a head start. We want to save as much time as we can by getting started early on in the design so we can address any issues right up front. The next thing, like I said before, is we want to qualify the contractor. I can't stress enough how important it is to make sure that the contractor is certified and to require that as part of the project scope. You have the ability to require that, so make sure you do that. If the contractor is qualified, that wall is going to be installed so much better. And then lastly, we really want to make sure that geotech gets involved early on. When they're involved early on, we can get all those soils information. If we need to do a geotechnical report, they can get started on that early. And when that gets done, we can start the design of the wall early, which we've talked about so many times. It's very important to do that. What I might add to these 3 points is the importance of having that site civil control the design rather than the contractor. We want to get rid of that design by others that we see so often, and really make sure that that site civil is controlling the design and moving through this process, making sure everything gets addressed that needs to be. But yeah, basically, chapter 1 is all about covering your bases. Uh, what we're doing, what we're going through in this first chapter is we're making sure all of our special considerations that are needed for the wall are used in the design of the wall. We're making sure every party that's interacting with the wall is on the same page, making sure all of our local and municipal codes are met, making sure everything that's needed by the wall installers and inspectors is available to them. Not only available, but also clear to them. And it makes sense in that we're there to answer any questions that they might have to, to answer any misunderstandings that people have. We're also making sure that the owner is providing everything that they need to provide, that we're providing everything that we need to provide as the engineer, and that the pre-construction process basically in general is streamlined and void of any last minute changes, because those last minute changes are what can cost so much money and time and delays, which best practices aims to get rid of. But in general, best practices focuses all around that proper planning. Proper planning is going to help us eliminate all of the mistakes from our walls, and when we eliminate those mistakes, we can really hit that zero wall failures that we're trying to, because one failure is too much, like I said before. So planning allows us to move from one failure even to zero failures, which is very important. So that is chapter 1 of best practices. Does anyone have any questions? You guys can go ahead and type any questions that you have in the box. Okay, it looks like we might not have any questions. Okay, well, if that's the case, I will, at the end of this presentation, after I end the meeting, I'll go ahead and put together a kind of follow-up email to send to all of you guys. I'll include best practices and that spec book as an attachment to that email so that you guys are able to see what I was talking about today if you weren't following along. I'll also include a video link to this presentation so that if you ever need to reference back to it or have any questions that might be answered by the video, you're able to, see that, watch that in the video. Since I'll be sending that out, if you guys have any questions that you think of after this presentation, feel free to email me back and I'd be happy to answer them. But with that, I guess if nobody has any questions, I will go ahead and end this meeting. Thank you all for attending. I know an hour is a valuable amount of time, so it means a lot that you guys were able to sit in on this. Yeah, Randall, I'll definitely attach the spec book and the best practices documents. Okay, I'm going to go ahead and end the meeting now. Thanks all. Bye.